Thanks for joining us here on Danamo Bim. Today we have Marcello. We're so lucky to have him. We are going to have a little bit of an interesting chat today in the fact that we are not going to present anything. We're just going to sit here and chit chat more theoretically about the idea of what is computational design. What's a computational designer? Why do people do this? How do you do it? How should you do it? Should you do it? I think that's what we're going to talk about, right, today, Marcelo?
Yeah, those are awesome questions. There's no wrong answer either.
I don't think so. I think if you were, though, to look up the definition or to ask the definition of computational design, it would probably be based off of data, right? You're computing in some way, in some form, and informing your design with that computation. Yeah, in whatever form it is. And so computing data in some way to alter the design path or design outcome.
Yeah, you said it right.
Is that like that's probably the generic, like if you put it into a box, what we're looking at.
Yeah,
Now, how you
yeah.
approach it
Computation.
is like way, way out there, right? I mean, there's
Right. Who
so many
cares?
different ways.
Who cares? Who cares what the definition is?
Yeah, who
I
cares?
do.
Because it's
It's like,
meaningless,
what could
right?
it do for me? Right.
Right. Meaningless.
Yeah. Although I was looking online, uh, and there are a lot of different definitions. Some really long, some really small. But yeah, I see it like you said it. It's the I think well, see, we gotta narrow it to AEC at least, because we can have academic discussions about what it means outside of AEC. But if we focus on the AEC industry, it's just like you said, it's the way to use computation to help support your design and the production of what you're trying to do. So that would be the design side as well as the construction side. And computation is the key. I think programming is the key. And I was in a podcast last week or maybe a week and a half ago, and we were asked that very same question: what is computational design? And I think the confusing part is that it's not a thing. I think it's a process.
Mm-hmm.
And so it gets a little confused. Like I think of it that way with like the word digital twin. I don't want to go off on a tangent, but that's the way I see digital twin. It's like, well, what's a digital twin? And didn't we always have it? Or, like I see a digital twin. It's not a thing. It's not a 3D model. It's the process in which you use it. Can't sit on a shelf.
I think it's very personal also,
It is
right?
personal. It is personal, which makes it awesome
Yeah.
because at its root, computational design is about customization. And so that you're customizing what you're doing and you're supplementing what you're doing. So that's what makes it powerful. So it has to be personal. If it's not personal, meaning that it's affecting what you're doing at that moment. And you said it. It has to be personal. Otherwise, I don't think you really have computational design, because computational design will augment what you already have. Because the thing I was thinking about this, it's like we're in another paradigm shift, which is the computational design paradigm shift. But we were here 10 years ago, or 15 years ago, or 20 years ago, however you want to have that academic discussion about BIM, and when companies started shifting over from 3D or 2D to CAD to BIM, and it being culturally accepted, a way you do things, a way you think, uh, and and I think we're in that next shift. And so computational design, I think, surrounds that idea and helps support and augment that culture that's already in your office. I think probably like sits this cloud that sits over it. Now, how you do that, of course, is always the hard part, but I think that's kind of what we're dealing with. It's a customized thing. So it's personal. I could ask you what computational design is for you, and then what for someone else, and it's personal. But in there, I think lies part of the problem, because because implementing computational design wholly within a culture of an office is sometimes a difficult thing, because some groups will use it one way, some will use it another, and then some people view it as separate things when they are really the same thing. I like to think of it as like the light and the dark side of the force. You probably know it, but it's like it's the force. It just depends on how you use it. So like it's computational design, whether you're trying to rename your sheets using visual programming, or you're trying to do solar analysis inside of Grasshopper. So like it's really the same underlying principles and
Well,
process.
are there buckets, would you say? Are there like different categorizations of how people accomplish or what tasks, kind of the umbrella kind of workflows? Maybe, I mean, kind of hinted at maybe workflow in terms of construction documentation, and then
Yeah,
workflow in terms of analysis and solar, information and how that can impact your design in some way.
yeah,
Maybe there's also a geometry side of that and the form of the building itself, and maybe that lends to the solar analysis.
yeah. And then on
Maybe
the other,
all of them are intersecting in some way,
yeah, and then you can even hop the fence. I don't like to think there's a fence, but the construction side, right? How do you extract data? How do you express that data to your fabricators and all that? And that it's useful there. So are there buckets? Yeah, I suppose, but I think it's all the underlying same thing, and how you go about doing it. So I think what's special is that computational design can help you no matter where you are in your process, and no matter what you do. I think that's probably what it is. And we can have a conversation like, okay, what about this? How do we support this? What about documentation? How do we build geometry? Best thing to use. But thinking, if we're just talking general, which I normally don't do, I like to go, okay, you want to do it? Click here, click there, click there, click there. That's
You want
usually
to
where I'm
build a
at. But if
rhino?
we're up, I'm sorry, what?
You want to build a rhino? Let's build a rhino.
I want to build a rhino. I'll show you how. But if we're talking like super high level stuff, I think that's probably where we're landing. What do you think about
No,
that?
I think kind of like we were saying, I think it's very personal in the fact that what you do as an individual, as a designer, as an architect, as an engineer, as a contractor is very personal, right? In what process are you brought into the program? What part of the program are you tasked with, right? Like what does that look like? Are you do have certain requirements that maybe some clients wouldn't, right? In the States, we have Kobe in some places that are required that, maybe computation might help with. There's this idea of BIM kickoffs at the beginning of projects. Now I think that there's this kind of idea, computational kickoffs at the
Right.
beginning of projects. Have you heard of
Those
these?
are awesome. Those are great. You commented, I think, in a podcast that
There's so
I
many
can't remember
chats
who
now,
said it.
right? It's
I
like
can't
there's
remember. I'm sorry.
chats
Yeah,
on chats on
there's
panels
lots of
on
chats, but at
podcasts.
some point, I think it was you. I heard you say that you have participated in computational design kickoff meetings, which are awesome, because that means that not just that means that the technology the technology and the process that you're using is being shared across the project team. So I mean, you can imagine have if you were in a position where like for example, we did this on the project we were working with co-architects for the Cal Poly Pomona new admin building that that finished construction, I think 2.5 years ago. Anyway, in that one, we were sharing um, uh, visual programming scripts, and so it would have it, at the time we were kind of loosely formatting it in some way, but like if I could imagine if this was pre-set up, you have a computational design kickoff meeting that would include how you how you formalize and standardize and share that kind of technology and process, I think that would be really exciting. I'd like to see.
It lends to the idea that it's personal as well, right? I mean, you have the idea that you're going into it with maybe here's how we as a firm have approached computational design in the past. And then you almost open it up to the team and say, how does this change your outlook now? How can we make this project more efficient and maybe look at it in a computational way, in
Yeah, I
some
like it.
way,
I like
right?
that. I like that. I like that because if you think maybe 10, 15 years ago, whatever, you were having your BIM kickoff meetings, there were times when on like a very in the weeds conversation, you'd be talking about, okay, well, the architect, you're responsible for this, 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 and this. Structural engineer, you're responsible for this, this, and this. Structural designer, right? Contractor, you're responsible for this, this, and this. And then you see gaps, like who's doing all the non-load bearing masonry walls? Who's responsible for that? Actually, there's a gap. Okay, who's going to take that? And it's a discussion. Well, structural engineer details it, but the architect figures out where it goes. Okay, so it's a gray area. Let's have a conversation and work it out. That in that way, I could imagine there being computational design kickoff meetings that fill those gaps too. It'd be like, well, who's laying out all the grids? Okay, laying out all the grids. Well, how's that done? Well, you know what? If maybe we could add to your script and we can flip all the grid bubbles this way, and then it'll help with our documentation or whatever. Or you can have conversations about extracting out data. Like I think that would be a good position to be in.
Oh my gosh, I got the best idea right now.
Okay,
What
what is it?
if just like you have a BIM execution plan, right? Because it basically the BIM kickoff is opening a narrative, right? It's like,
Yeah,
okay, here's the outline, and this is a living document
I think I know what
that,
you're going to say, but go for it.
that we're gonna outline and edit as we go through this project. Now we have a computational execution plan. And now we're gonna say, okay, these are maybe at the top, right? These are the scripts that we have, and these are the custom packages that they require, and this is the version that we're using,
Let's do
and
it.
Grasshopper, all the things, and these are the different ideas, intents,
Let's do
workflows,
it.
maybe even some different diagrams of how those different things are executed.
I love it.
Note this data must be there in order for it to work.
And
Right?
the BIM conversation is part of it, right? It's part of that
Absolutely.
conversation.
It's all tied in.
It's all tied
It's
in.
almost like
I
an
think that would
appendix
be a
to the
great.
BEP.
I'm sorry, what?
It's almost an appendix to the BEP,
Yeah,
right?
right.
It like
Right.
goes hand in hand.
If it's a project requirement, then it's an appendix or a supplement, or maybe in the future, it's just
A
an
chapter.
owner driven requirement. And then we're stepping back a bit further because normally when you hear computational design, a lot of the conversations are very narrow focused. Show me how to rename my sheets. Show me how to do solar analysis. But we're talking a bit bigger picture, which is how do teams, even outside their discipline, structure, architecture, talk to MEP, landscape, civil, uh, structural subcontractor, right? And no, this is a good place to have our conversation. I think that's where we're kind of floating right now. Let's stay there for a moment. I think one problem in our industry is that there's not a lot of transparency in within team members outside the disciplines, each other's disciplines, on what they're doing, and this computational design. Let's plan. I'm going to remove execution for now. Let's just say plan gives clarity to what's happening, and I think that is the first step, because a lot of firms do have little pockets of groups that do things, but then I don't really find it, even from my personal experience in projects I worked on, I don't really find it to be something that is the top of our priority list to share with other team members. Like, listen, we ran this script, we made this, it renames all our sheep, it reorganizes our view browser, um, and here it is. Like, that tends to be a bit more personal, and I think, and part of the problem is it's kind of kept a little bit closer to home. But I don't think it's probably not done that way because it's like we have to keep this. It's probably more of that way because they don't think anyone is interested in hearing about it. And so I think probably to get to the level we're talking about, where you're making computational design plans, execution plans, I think if you had teams that were open about it, like, listen, tell us everything you're doing, show us all the tech you're using. We totally would love to absorb and be part of it. You know, that opens up a whole other conversation. Oh, really? Yeah. Okay. Well, oh, that's awesome. Can we use that script? Or hey, there's a script. You know, and that I think that's the first step to this, because we're talking about, we could do a class on computational design execution plans, but if no one ever does it or no one ever read it, then what's the point? So I'm just kind of thinking a little bit. I think it's a great idea. That's definitely where the industry should be. But I'm already starting to think, like, how do you get people there? And I think get people there is to adopt this mentality that people are interested in what you're doing, and you should be sharing it, because that's you'd be surprised. Some projects I've been on, I've been sharing, like, we built these little hat channels. We were working on the LAX project, and I built all these little steel hat channels on top of beams using Dynamo. And initially, when I was laying it all out, I didn't think anyone would care. I was like, well, that's how I did it. But I showed the architect, and they were like, oh, that's great. Can you show us, like, how you did it? How'd you lay it out? And I was like, oh, of course, I'll show you. You know, and it led to these really nice conversations and collaboration. And so I think that's part of it, is the transparency layer. If we can work on that first. Sorry, that's a lot I threw out there at everyone.
No, I think it's exactly that, though, right? And I think rather than even me as someone who thinks Dynamo is really exciting and all the
You do think that?
computational workflows that, you know, could be done, automating Revit tasks is exciting in itself, right? I think is really cool. Or Rhino tasks, and, you know, bringing the Rhino geometry into Revit and doing all of these computational ideas are so cool. But I think that the challenge occurs when I start to think about, well, okay, if I share this script, what's gonna be included in that? Now I'm gonna have to document this in some way to say that, okay, now you're gonna need XYZ package, and when you open up Dynamo, you're gonna need to navigate here, and you almost need to, like, go back to basics, because I don't know who my audience is, right? This could be somebody that's never opened up Dynamo before ever, and doesn't have any custom packages on their computer at all. You know, doesn't even have a Dynamo folder yet on their C drive, you know? So those types of questions are what Autodesk doesn't necessarily make it easy for us in that
No,
sense.
they don't. I mean, well, I agree with you. I think, well, okay. I'm going to back up and say, I agree with you that that's a challenge. I do. I think what's going to happen here is, if we're talking outside the office communication, is I think how your computational design processes are used within an office is an easier conversation, because you know the individuals are going to use it. You're setting it up for, like, your users through Dynamo Player or whatever. You can teach them classes on how to click here and use that. When you start branching out and you're sort of, okay, we're going to give this to the contractor so they can extract data out of the model, whatever, right? Now you're in next level stuff, right?
Well, and so
But I
maybe
think that's just
I'm
the
going, like,
natural
way
progression.
too far, right? Like, maybe I need to, like, back up a second and just say, okay, within the team that I am a part of,
Okay, let's start
what
there.
are
But we
what are
gotta go back to the let's get back out to we'll go back out there later. Okay, go ahead.
Yeah, we'll definitely go back out there, because they're gonna want to know. They're gonna want to use
Fine.
this stuff,
You're right,
right?
totally.
That's gonna
Yeah.
eventually be a place where we have to go.
Okay,
But
fine. Let's
to
talk about
start,
what considerations you need to do within your office. Okay, go.
or even just within this team, what requirements do you have for this project, which would require some sort of computational analysis or workflow incorporated in some way,
Yeah,
right?
no, that's a good question. Yeah, it's a good question. I think
And then
I think
also,
it
like, hey, these are the 10 things that every project should be using because they align to our standards internally, you know?
yeah. I think I think what I think the most basic way to look at it is you have the process which you have now, which is kind of the status quo now. Let's say if you weren't using computational design, which is you have your BIM and your BIM processes to do what you need to do, and it's working for you. You may not as efficient as you could be using computational design, but you do have a way of doing it and making money. That's why you're still in business and you've survived so far. So you do have a standard, you do have a way of doing something. And I think that's probably the way to look at it. I think then as you think about using computational design, how do you supplement that current effort, current process to make things more efficient and better? And then that's where you kind of build upon, because even me personally, like I've done like, I've written like programs, add-ins, computational design, supplemental thingies, I'm just going to call them thingies, to people's processes who've ultimately rejected it because they were happy with doing their current process. But I think if they really, really knew how much it could help them and be more efficient, then and how easy it would be to implement that new process, then I think that's when you get breakthroughs. And it's hard because you're kind of in a system of doing something, right? Do it, you model it, you document it, you send it out the door, you coordinate it, you get on the phone, you do more coordination, you do more design, you document it, and it goes out to the building department, right? Like that, this is all the BIM process we normally use, but like, how can we supplement that? How can we make it better? I think that's probably the place we have to start. Now, I know you personally have done a lot of that already at your company, Smith Group, where you've augmented people's process to make their lives a lot easier, right?
And part of that is just teaching them that it's possible, right? Like planting the seed of, you're going to do this extremely daunting, really logical task for the next 4 hours. Maybe computation could help in some way. Like, let's have a conversation about it. You don't even need to know how to execute it. Right? Just knowing that it's possible.
Okay. Yeah. But you still give them the option to not use it.
Of course.
Of course. Okay.
If they want to do it
Now we're getting
manually,
somewhere.
they can.
I'm sorry, what?
If they want to do it manually, they can.
Yeah. Okay. See, now we're getting somewhere. So let's branch out a little further than that. So I think we're saying, show them how it could help them be more efficient. Right? Like, how do you branch further than that? How do you branch outside your group? Right? Like, sometimes you have groups. You've got like the BIM group, which may be involved with the production of the product. So that's like coordination. That's like organizing the designs that happen. Maybe supplementing visualization that may happen. That's making sure that the sheets get done, that your instrument of service is complete, right? There's a lot of times there's that group that does that, right? How do you branch outside, if that was your group, how do you branch outside that to work with other groups? Like, you may have a group in the office that does the actual modeling and design. How now, like, I'm interested in, like, I'm in there, and the listeners are probably interested on how you help solve that problem.
Well, I think first you have to ask, are you just a single discipline firm, right? At Smith Group, we're multidisciplinary, which is somewhat new for me, right? So a lot of the time, not in every case, but in many cases, our architectural and our ME and or P are the same groups, right? Where they're internal to Smith Group. And if we're really lucky, we have landscape and civil and structural all in the same team from Smith Group. And so to say, hey, we're all using this script to make sure that our sheets are numbered or our key plan is accurate or what have you, is really advantageous for groups like that because everything is internal. We're all on the same system in a way. We're all aligned to the same standards. We all number things the same way, right? We're all under the same umbrella.
In theory.
In theory. In theory, different offices and different groups sometimes work a little differently, and that's okay.
Yeah, we're with you.
However, when you look at individual project teams, then you start to look at, maybe you're agnostic a little bit of your company standards, right? Because client standards and client requirements in a lot of ways trump those standards. Or your client could come in and say, I don't want my sheets numbered that way. And they'd be like, okay, how do you want them? Right? And we'd most likely comply to that system as long as it didn't break the jurisdictional requirements or whatever, right? As long as we didn't have a good reason to not do it that way, right? So then we start getting into well, our client is requiring us and paying us to do it in a certain way. And we, as the architect or the engineer or what have you, have developed this method, this computational workflow, whether Grasshopper or whatever it might be, that maybe could be shared across the team because we're all on the same team, right? We're family here. We have all the same goal in mind to finish this project in a good, efficient way. And so then, you start hopefully getting into the BIM execution plans and, how do we all play in the same sandbox and get to that deliverable on those dates together in the same sandbox, right? So I think in that way, we start to, hopefully, because the BIM execution plan is somewhat related to workflow to get to that end deliverable. Hopefully we can, the conversation of computation naturally starts to come up, right? I think in some ways the computation plan or execution plan starts to force it to be part of the conversation.
Yeah. And when you brought up a good thing, which is the conversation, right? I think having the software solve certain things, like, I don't know, you want to have the design groups work with the production groups. Well, now Rhino inside Revit can help take your Rhino designs into Revit, right? That's an easier conversation because the technology can do it. You can have conversation. The harder part is to get the individuals to work together, right? And I think that's probably another speed bump for this process to work. And because they probably traditionally don't. I mean, from what I've seen some companies that do and some that don't, but you get kind of on the other end of the spectrum, the ones that don't, they're like, well, that's the production group. I give them my design models and I let them deal with it. You're like, but are you talking with them? Because there's something you could do to change your ways to help them. But they, that's their job to work with what I have. Well, are you in that process? Are you having conversations with that? Are you putting things in a certain whatever, And I have seen a clear, sometimes, a distinction between individuals, even within a company, having different roles and thinking that this technology is not the same thing, that's really different things, and so they don't need to bother with it. When in fact, as you're saying, it is the same thing. There is one plan. It's a computational design plan / execution plan. So we all need to be having this conversation and working together. Made me think of another thing. Maybe I think because this technology is so new, there are pockets. I don't really see a lot of oversight with the tech. Maybe maybe we could Google it, but I don't see computational design directors yet. I don't see that next level oversee of like, this is the tech, this is it in the office. How is this group or individual or management structured that pulls in all the entities that are using it, plus talking with marketing, sales, like it would be within to be kind of culturally accepted. I know there's directors of design tech, right? That may be kind of part of that process. But I don't know. What do you think?
Well, do those groups exist? Do computational groups exist? Like, do computational designers, is that a role? Are firms hiring people specifically to be a computational person, right? Like, unfortunately, my role isn't 100% Dynamo. I wish it was, right? But are people being hired for that? Is there is there somebody that comes in, even on the project level, to say, especially on the project level, to say, I am the computational person on this team. And is that person just an architect, not just an architect, but an architect, an engineer, also part of the production team? Is computation supplementing what they are required to do, or is computation supplementing what everyone is required to do because they think about it from the team level? Does that make sense? Am I asking that question correctly?
Sure you are. I think it's coming back down to the same thing, which is how is this organized and structured in such a way that everyone can take advantage of it? And it's not just us against them. It's
Exactly.
it's us, and we're all in this together. And let's come up with a good solution for it that we all are kind of talking together. I like, yeah, even
Right.
within a company, first of all, right? Yeah, I think that's good. I think
Or
another
like,
thing too is,
does me as just like not just, right, but someone that is tasked to be on the production team. Do I have somebody that I can go to that understands computation on a different level? Maybe that's even allotted to my team specifically that I can ask, is this possible? Can something like this assist me computationally? Are there
you said it.
resources in place for me as someone who is in production that needs help computationally?
Mm. Well, first of all, it's a good question to ask. Is there someone that can help me computationally on this task? That's the best. I never really thought about it, but that's the best question to ask, because that's the idea of computational design. It is just that. I think probably what you'll find is that there are individuals like yourself who who are responsible for those kind of things. Yeah. I think what we're talking about is a cultural shift where it's like everybody, like if you think about BIM in an office, if you talk to marketing, marketing's going to know what BIM means. You'd be like, right, we got it. We've got a BIM page on our statement of qualifications that explains everything BIM. Okay, where's your computational design page on for your statement of qualifications? Wait, what? Yeah, where's that? Wait, what? And it's the wait, what, that it's not this cultural adoption. So I think the cultural adoption is part of our conversation, which then would probably foster the, okay, Dana, you know what? We really need you to officially be the XYZ, or, whatever. I don't know. I'm just saying that's probably where you have to go, because I think even just if you look back at BIM director was, it wasn't you had to kind of adopt it culturally and say, yes, now we really need to officially make something here so it's more formalized. So this culture we talked about, then it's like, okay, well, how do we standardize it? Well, let's make an internal computational design execution plan. How do we deal with the team? We're hiring structural engineers as our sub-consultants. Well, then let's get them in on that computational design plan, right? Like, I think that's probably the natural progression of this. And the podcast I did a few weeks ago, I was thinking, I think another thing that could help with this adoption, if I was thinking about the BIM thing a long time ago, is owners, clients, like you said, right? If they're knowledgeable about what it is, they can help push this tech, right? Like you get, right? Like, I mean, if you got, I don't know, one of your big clients, say client X or Y, they started saying, hey, listen, are you using computational design on my project to be more efficient? If you heard that, you'd be like, whoa, yeah, okay, let's formalize it. This is what we're doing, right? Like, I think that conversation will go a little different. Okay, where are your subs? Are they using computational design on my project to make my project more efficient? Oh yes, we've got a structural engineer on board. We've got a landscape architect. They all are using. Oh yeah, okay, and here's our computational execution plan, whatever. Like, can you imagine that scenario? Like, I think that would. I'm just thinking, maybe we work it from the ground up and from the top down, and then in that way, maybe we'll get cultural adoption.
Or maybe we as designers and practitioners, we start saying, I don't want people on our team other consultants as part of this umbrella that don't have a computational understanding.
Yeah.
Is that being mean? Am I being
Go,
mean
yeah.
by saying that? I'm like
Yeah. I
telling,
mean,
I'm
if
telling
you're an
you like you're not
architecture
part of our
firm and you went
club.
to, if you're an art, I mean, I could imagine, we're getting controversial here, but I imagine if you're an architect and you were the prime designer and you're hiring all your sub design consultants and you told every one of them that you need to see their knowledge or expertise on computational design. I'm sure that they would want to, if they weren't, they would want to step up to the plate as quickly as possible because they don't. They'd be like, well, if you're not, then I'm going to find someone who is. Right? I think
And I
owners
think
can do the
just
same
like
thing.
BIM, it just like exactly where I was going,
Okay.
just like BIM.
Right. Owners said that. Owners said that to architects, and owners said that to contractors on design build projects. Right. So, not all of them, but that helped some of the adoption. So, I think, yeah. So now go bring it all back around. How do we get started with this? I think you get individuals who are not who are hungry for learning computation, and I think that's a lot of things. I think that's probably programming, but it doesn't have to be text programming, right? I think that we're having this conversation now because visual programming has brought computational design to the forefront because it makes computation and programming a lot easier because we've got Dynamo, we've got Grasshopper, we've got others that other methods that make computation a lot easier for AEC professionals.
Do you see that like often now, like even structural engineers that have
What?
this idea or like this concept of that it's integrated into their workflows? Like, is
I,
that
I
becoming
am,
a
I am
thing?
seeing that. I am seeing that. I am seeing that. Okay. Yes, I am seeing that. Particularly with the very large structural firms, a lot of them are using computational design and their engineers are thinking that way and are used to that. And that's just kind of a natural progression of
Is that
what
based
they
out
do.
of calculations and analytics and that what, structural loads and different things like that that you guys do on a design basis from the
A
start?
lot of it, a lot of it is based out of need, quite honestly. In the structural subdiscipline, I mean, could have can have other people chime in, but in the structural subdiscipline, a lot of the structural analysis software that does a lot of the stresses and internal stress and strain calculations and all that, they've been around a long time, and the ability to modify them and supplement them with automation is extremely helpful because a lot of tasks that structural engineers do are very repetitive. Um, Design a beam, get a deflection, check it. Get drift, check it. Get micro modification, check it. Make another modification, check it. Make another modification, check it. Sort of good, not quite. Make another one, check it. Like I've done it. I've done it hundreds of thousands of times. So it's it the the firms that have adopted it, some kind of computational design. Uh, I've seen engineers take great advantage of it. Structural engineers take great advantage of it. You're just asking personally what I've seen. Yeah, yeah, totally.
So what does
Not
tomorrow look like? How do we get this culture shift to happen?
well. I
Just
think we all have.
people understanding that it benefits them in some way.
Yes, I think we all have to do it. I think we're all responsible for it. So maybe you and me and podcast you're part of, all that. I think can all contribute to to getting the word out on how beneficial it is to your current workflow. And I think convincing people that it's easy. Like, here's the thing. I see it this way. The reason Dynamo grew like wildfire so quickly and so fast is that it had three key elements. One, it was easy to use / learn. It was practical, and it was inexpensive. And I think you combine those three things into processes in AEC, and they become clear and adaptable. So I think probably one more would be non-disruptive. So if the conversation could happen around, listen, you have a current process, we have something that won't be disruptive to you. It's just going to add to what you have. It's efficient. It's easy to learn. And we could do it in stages, and and it could be that aha moment like you had with your key schedules, right? Like, it's like, wait, I don't have to rename my sheets. I don't have to open up every single sheet and change the A to an S like 100 times. No, it's just this little thing. Wow. And then that kind of sparks it. And then so you have to kind of show people in one way or another, however that is, the benefits. And from there, I think that's where it starts. And I think it should be all across the board. I think it should be from the ones in the trenches. I think it should be the managers, the principals, the owners, the marketing group. I think it should be all of them.
The fabricators.
Oh, yeah. Of course.
Everybody.
Yeah, everybody.
The maintenance people.
Yeah.
How do we get them to
totally.
use it?
Yeah, can you imagine
Usually the full life cycle.
Yeah, can you imagine like talking to a facilities manager and said, hey, listen, all those light fixtures you have in the model, you need to replace them in 2 years, right? Yeah, well, okay, you know what? Here's a script that'll run them and tell you exactly where all of them are and how much life they have left in them. So you can schedule now for 2 years from now where you need to be replacing them, and it'll geolocate it for you. Really, yeah, and we could put it into a game engine. You can virtually walk through it, and it'll find. And really, I can plan that out now. Yes, of course. Those would be really beneficial, I think, for facilities management. The point is, yes, I think everyone could benefit.
So I guess what we actually need to say is we need to put a message out to the owners.
We do. You know what? And another challenge is I think we need to get them out to the building departments too. Somehow we could do that.
We need just
like
imagine
in Virginia, you have the building officials, right? We need to get them on board too. I don't know how to do that. They're part of the equation, right? Can you imagine if you turned in your drawings and a 3D model as a reference, and a building department official said, hey, listen, if you have any scripts of that you use for this, we would like to have them just as a reference. They're not official, just as a reference. Like, wouldn't you be like, right? Can you imagine?
Absolutely. I think that's what message to owners. Computational design exists and can make your projects much more efficient. Start asking for it.
Yeah, so I think there's two things. One is a campaign for owners, and two, a campaign for the production kind of people, which would be maybe that computational design execution plan. We're calling it that for now. For everyone.
So the CDXP, CDEP.
For all team members, one. and then the computational design 101 for everyone as well. Marketing, owners. I think it'd be a good place to start.
Yeah, broad umbrella. You don't even need to be in Danamo. Just this is what can be done with computational design, right?
Yeah.
Not the points and the clicks, the theory.
Yeah. Yeah, and maybe the ones who are like further removed from it, like marketing, you could be like, hey, you know what? You wrote 20 reports last week on this. You know what? I'll write you a Danamo script that'll go into all your Word documents and pull out little snippets that surround paragraphs for this particular explanation on BIM or whatever, and we'll collate it for you and put it in an Excel spreadsheet, right? You could even show them how computational design can help them. I'm just thinking out loud, but maybe they'll see the merit too, because it's more real for them. So when they're writing a report on it or whatever, or they need to explain what it is, they'd be like, oh yeah, we totally got this covered. We know what it is.
Well, thank you so much for joining me today, Marcello. That was a fantastic chat. I'm really excited about this. I think that we are really going somewhere with this CDXP.
Yeah, that's good. I like it. I like this. This is the format I like.
An idea was bred.
Yeah, an idea, and then like, okay, now what? What are you going to do about it?
Now what?
I think I say this in the end of most of my podcasts. It's like, we talk about a problem, but like, okay, we need to be part of the solution, right?
Mm-hmm.
Yeah, and so Okay, good. Yep. So now what?
Thank you so much for joining me.
Okay.